He is Andreas Kind. He is with IBM and he leads industry solution and blockchain at the IBM research. And now we get an inside view of what IBM is thinking and is researching. An applause for Andreas Kind.
Thanks a lot, Rico. Yeah, a good day to all of you. I'm very pleased to be here. Thank you very much for the invitation. I am with IBM Research. It's the science and innovation part in IBM. And here we have a topic that indeed requires a lot of science and research to make it real for business. So this is really the context I would like to address this topic to you. The story and the motivation for blockchain comes basically through the fact that almost no business operates in isolation. There's always a network. There are partners, there are suppliers, there are manufacturers, there are financial partners as well that provide financial means for business, and there are regulatory bodies as well. So it's always a network. And this network maintains on all their points the state of transactions, basically a ledger that exists at all these ends. And this leads to a lot of duplication, a lot of inefficiency, a lot of disputes as well, because these ledgers, they may be not exactly in sync. And also, these ledgers can be attacked, so there's a possibility that from outside, people get into the ledger and see information they should not see. So the promise of blockchain is really to have one shared distributed ledger. It's basically like a replicated database with very strong consistency requirements. And it works basically that there's software running on each end that maintains a copy of the ledger, and there's a protocol spoken between these ends that makes sure that the state of these instances are completely in sync. That's not trivial, because you have to be careful not to allow double spending. You have to be always completely in sync between these instances. And there's also a strong requirement for provenance, that nobody can change the history, because this is what a ledger is about. You add a line in your book, in your ledger that represents the transactions, and you would never change anything in the past. So this is the big picture, basically providing a global truth between different business parties. And I would like to basically go a bit more in the detail when I say blockchain for business. What is this enterprise grade that we believe is really required here? And it starts basically with the first of the four aspects that we typically discuss in this context. It starts with the shared ledger. It is this append-only data structure where transactions are added. And in order to have access to this shared information where everybody writes their state, their transactions into, you need an entry point. So this is the first premise that we think. There needs to be an entry where organizations or individuals register. They get what is called an enrollment certificate, basically the public-private key pairs that they generate, they get encoded into a certificate. And with this certificate, there are then transactions that can be made in an anonymous way. So the transactions on the ledger, they remain anonymous, but still there is an entry point where you need to be registered. And then the transactions, they have to maintain the privacy that different organizations need. They have to make sure that the confidentiality is maintained. Certain groups of participants in a network have confidential data to exchange. You could have special contracts between selected parties. And you have to make sure that when there are anonymous transactions, these are also unlinkable. So you can have anonymity, but still through observation over time, you could sort of guess who's behind, just because the same keys are used over and over again. So there's certain tricky ways of implementing, basically balancing the strong requirements for anonymity, confidentiality, privacy, but also auditability, because fact is we live in a world where we have in many industries regulatory bodies. So we have it in finance, definitely. We have it in the airline industry. So in many areas, in the food industry, in healthcare, definitely, there may be certain parties in this network that have special rights for turning around the cards and helping to reveal who is behind a transaction. Anti-money laundering is one clear example where in a particular case you need to have the possibility for one partner to turn the cards. So next to this shared ledger that is sort of an open truth, and the control mechanisms that make it not completely open, but open in a controlled way, there's also a very specific need for consensus. And we heard before, one way of doing consensus is a proof of work mechanism where transactions are committed in a distributed fashion. We believe we need also here very strict requirements with respect to repudiation, with respect to the throughput, the latency involved. And there's a path really to be developed where we definitely need to reach like thousands of transactions, because this is what typical business networks need. We will never make it into a use case where you have real-time trading, for instance, but the settlement part, where there's still a lot of delay, may well be a good use case for blockchain. And here we need like a large throughput of transactions. Also, the finality is very important. You have to know in many business situations that the transaction is really final. So nothing can be rolled back because of some delayed form of consensus. And the consensus algorithms that basically fall into two classes here. You have the proof of work systems on one side, and then you have the Byzantine fault-tolerant protocols, where there are certain forms of more practical ones that can surely scale into this range, of course, with a much smaller number of participating nodes. But through the first statement that we say we need an entry, we basically think we need a permissioned blockchain in a business enterprise-grade blockchain system. Anyway, the number of nodes is much smaller than in a completely anonymous open blockchain system. The last part here is we believe we need a good programmability for smart contracts. Smart contract is a really powerful concept. It allows to really encode in a very secure way business transactions where you have a traceability, where you can really control the access to assets and the transfer of ownership. But we need basically an environment where you can program almost in the same way. So there are ways of using, for instance, the traditional languages like Java or Golang, and just capture them in a virtualization container, like a Docker container. So this is one way of ensuring that in institutions where you would have already many people developing smart contracts, they can basically reuse their skills. They have to learn some APIs, of course, but they can basically reuse their language skills in order to develop smart contracts. And also we have to make sure that system security is provided. So there are ways of having these smart contracts run in very secure enclaves and very secure containers, and restricting the access that these smart contracts have on the underlying compute infrastructure. So for IBM, it was a bit like we saw blockchain as really something that touches our core business model. It was always about business transactions. Every database is about this, every middleware, every mainframe. And this new paradigm basically, told us we have to do something. There's something coming up and we better be ahead of this. And by the way, in research, we had already for many years work ongoing in distributed protocols, distributed trust systems, also from the cryptography side, these advanced distributed cryptography approaches. These are topics that we always wanted to basically see in an enterprise and an applied side in IBM. So there's a history, but of course we couldn't possibly do this as a proprietary system. So we co-launched a project in the Linux Foundation, and this project is called Hyperledger. In particular, the blockchain core part is this called Hyperledger Fabric. And it is a tremendous success story. So it was within sort of few months, really, the number of participants went up. And you see here, it has reached like over 120 members by now. And from the logos, maybe it's a bit difficult to read. It's really big names here. Even other blockchain consortia, like R3, for instance, are part here. You will find Swift here. You will find JP Morgan. Many sort of large organizations, not only from the finance industry, but really cross-industry. I would like to touch on some few use cases just to illustrate what blockchain can do. The first one is really not a finance one. It's the airline industry, a heavily regulated industry where you have the suppliers, you have the manufacturing, the aircraft manufacturers that build the airplanes, you have the airlines, you have the airports, you have maintenance and operations. Then you have the regulatory authorities, of course, that make sure that everything is according to the standards, and all have a stake in this business. And when there's a security issue, you really want to find out what's behind. And it could go back to the point where certain parts of the plane were supplied during the manufacturing process. So imagine you would have a ledger that gives you exactly this provenance of an airplane. Really going back from manufacturing into the operations, the maintenance. When there was a hard landing, there are clear regulatory requirements for checks depending on the hardness of the landing. So was the weather part of it? Was the rough landing track part of it? So all this could be part in a ledger and used once there was an incident to find out what was the root cause. A second use case is in trade. And it's very often quoted, a situation where, again, there are multiple parties. They don't fully trust each other. They might not even know each other. You ship things from another part of the world into another continent, and you would never pay somebody before receiving the goods and vice versa. So the typical way is to have a letter of credit, and then based on the letter of credit, the things would start. There's a bill of lading then when things are put on a ship. But there's a lot of risk, and the very first picture that I had in the presentation sort of alludes to the risk and the things that could go possibly wrong in these long-lasting transactions. And today, it's very old-fashioned, basically. There's a lot of paper involved, a lot of manual processing involved. Again, imagine you would have a ledger where everybody would have visibility, including port authority, including the customs, and all the different parties that have a stake in these long-lasting transactions. And there's actually also not just the possibility to take out friction that clearly exists here, but also to come up with new innovative ways of doing trade finance. And we're very happy to be in a partnership with UBS here, where we investigate what could be these new trade financing products. It could be maybe something that connects the best of both worlds, the letter of credit, which is heavyweight, expensive, but it brings down the risk, with an open account approach where you have higher risks, but it's much less costly. So bringing these two worlds together using blockchain is a very interesting way of sort of coming up with new innovation in trade finance. I would also like to sort of highlight that we have a collaboration with Maersk for global container shipping. Here's the sort of crazy situation that sometimes these containers arrive before the documents arrive. So if you ship things from Mombasa, Kenya, into the port of Rotterdam, it takes very long. There are many, many documents, again, that need to be signed. It's certificates of the goods. It's like customs documents. It's, again, the bill of lading, the credit documents, and so on. So would the port know in advance? Would the shipping company know in advance? Would there be this global truth, the visibility into these transactions, these shipping transactions? What is on the ships? There could be a lot of optimization brought into this. So how you unload the ship? How much space do you need in the port? How do you sort of, when things are transferred into another ship? How do you organize this well in advance? So another example, diamonds, we heard about art before. Diamonds is similar. You want to know the provenance, the same way as you want to know the history, the provenance of your expensive piece of art. And we're very happy that sort of IBM, through Hyperledger, is part of the system that helps to give you the provenance for diamonds. So in a very expensive good where you really want to know where these diamonds come from when you buy them. There is a range of other use cases. I touched a bit on the finance ones, so trade finance and public. There's a lot about registries. Land registries in some parts of the world are a complete mess. So using blockchain that would hold a registry through a number of organizations, including NGOs, potentially would help. Supply chain is a big topic. You want to find out also with respect to food safety, for instance, where do products come from? It says bio on my label here. Does it really mean that it was like a healthy cow somewhere at the end? Then in manufacturing, very interesting, this trend towards Industry 4.0, where parts get printed at the point when they're needed in the assembly process through additive manufacturing processes. You end up with much more trust issues because the printer is owned by the supplier, and the supplier would be very careful not to reveal the blueprints that basically drive the printing mechanism. So here again, there's the need for different parties to have a trusted way of interacting. We heard a lot, blockchain is also hype, so many people talk a little bit too much about it and relay just information. I want to point to some real projects that are ongoing. So CLS is about international netting. So there's a very interesting one. When you have these large international payments, there is a netting going on between the banks that is now being investigated between CLS and IBM. I personally was involved with China UnionPay. This is about basically everybody, you know these reward point programs. So you have your credit card and then you collect points, and then you get offered to buy something in a store. Probably you don't need anything there, but since you have the points, you don't know what to do with it. So in China, actually, the idea was, and China UnionPay is a mandate from the central bank in China, the People's Bank of China, to basically allow interoperability of points, of these reward points between the different schemes, so that I can put my points together with my wife's point, and we just go to another store and just use these points. So they would not expire, and it would be for the consumers actually the right thing. So there's a concrete project we did based on Hyperledger. And also inside of IBM. So we provide financing to match suppliers and partners. And it used to be that we had a lot of disputes. So things were just wrong in these transactions, and there was a lot of friction. So now we use a blockchain system to bring down these disputes, because there's a global truth, there's a ledger. Everybody can go back and see what's behind the transaction when their goods are shipped. There is a lot of worrying. Do I have to throw away my entire IT? How do I gradually go into this topic? It doesn't have to be like this. You can start small, and it can be just basically a shadow ledger on top of your existing infrastructure. Nostro Vostro is one of these situations. Very difficult to consolidate the positions with other banks. It's a complicated process. It takes a long time, and it happens typically only once a month. So if we had a possibility in real time to see all the positions, it would be great. So having a blockchain system that gives me a shadow ledger on top, where I could immediately see the total of my positions, is an example where you can just, for compliance or for internal consolidation, introduce blockchain. And this then goes on with opening it up towards other banks, other partners, or really putting assets on a blockchain. It's a bit more risky, of course, but the value could be much bigger that you get back. And finally, having really high-value assets that you do the settlement, maybe things like over-the-counter trading between institutions. So it's a gradual approach that could be done. So I said, I'm from research, so I want to share with you also the agenda that we have. So a lot in the Hyperledger context actually comes out of research, comes here from Zurich, the research lab that we have in Zurich. In particular, the consensus part and the security privacy part that was implemented here. We have a couple of other things on top of this towards more usability, more applicability, because we hear all the requirements coming down. So consensus has to be fast. So there's now an optimization of, first of all, you can use just crash fault tolerant protocols, where it's okay in an environment where you trust basically the systems, but you want to address the situation that a server crashes or one node crashes and just comes back arbitrarily. But if you really have, a potential adversary in the network, you want to go with Byzantine fault-tolerant protocols, and these tend to be less efficient, message-bound, compute-bound. So having an optimization on this for default cases is one research direction. Then identity mixes, attribute credential technology based on zero-proof technology. We heard it before as well. This is very interesting, particularly when you derive transaction certificates from the enrollment certificate that you have. You don't want to tell anybody that you generate these certificates, and you can prove certain attributes based on these protocols. So there's another integration. And then we go towards schemes like distributed cryptography, multi-party computation. There are some really sort of magic approaches where you can introduce even stronger cryptography in order to achieve the consensus, where you have shared secret approaches, where you have what the consensus algorithm done, supported basically through cryptography. And the last bit I want to touch on is what we call Iot Crypto Anchors. So very often you worry, what I have in my blockchain system, in my database up there, does it really relate to the physical object here? So when I talk about food, for instance, how do I make sure it's not just the SAP system that feeds my blockchain system? I need to have some way of anchoring, basically, the asset that is not a computer. It's not a device. It has no IP address. It has no battery with it. It's a piece in an airplane. It's maybe the brake in your car. So when you get your car back from maintenance, you want to be sure it's the original part and not a counterfeit part. So how do we anchor something in these devices? And there's a lot of research going on, very, very interesting. It's basically about having on a nanoscale, like an anchor, a cryptographic anchor, basically a mechanism of tagging your product in the right way so that you can be sure the entry in the blockchain system really refers to this physical object in the real world. Yeah, with this, I would like to conclude, and I hope I conveyed the message. We need something like a blockchain for business, and there are some ideas. Thank you very much.